Hey team, we made it through part one of Dr. Sikora's lecture. Sometimes it helps to hear somebody else explain a concept, so I just wanted to take a few minutes to walk you through these predicting genetic combinations practice problems. To remind you, this is not something I'm going to have you hand in. This is just for you, just to be able to practice. This is a concept that will absolutely show up on your genetics test, so I wanted to give you the chance to kind of practice this and play around with it a little bit so that you know what you're doing. To do a quick review of some of the terms that Dr. Sikora uses, number one is genotype. These are the genes that the animal carries, what their genetic code is. Homozygous means that both versions of the gene are the same. Heterozygous means that both versions of the gene are different. And allele is a term for a version of the gene. So for example, if we're looking at our male on problem number one here, he is homozygous for gene A, which means that he only has one option that he's going to be passing on. But he's heterozygous for gene B, which means that he has two alleles for the same gene. Another word that Dr. Sikora uses a lot is loci. Loci means location on the genome. This is also a term for the gene. So anytime you hear him use the word loci, you can just like substitute the word gene in your head because it kind of means the same thing. So to review from biology, you carry two copies of every gene, one from your mom and one from your dad. When a cell goes through meiosis, in order to split into sperm and egg cells, the genome only breaks down into one copy. So what we want to look at for this activity is we're trying to figure out how many possible different sperm an animal is going to carry, how many possible different eggs an animal is going to carry as far as genetic combinations goes, and then how many potential combinations there could be if we cross that male and female together. So I'm going to start with number one. These problems get more and more complicated as they go down, so I'm going to start with the easy ones just to kind of walk you through it a little bit. So starting with number one, looking at location A, or gene A on the male, he only has one version of this gene that he's going to pass on. He's only got one allele that he could potentially pass on since he's homozygous for little a. So for the male, I'm going to give him a 1 right above his little a, little a. Looking at gene B, or loci B, if you're Dr. Sikora, he has two versions of this gene that he could potentially pass on, a big B and a little b. I'm going to put a 2 right here. In order to figure out how many potential combinations there are in the sperm, I'm going to take 1 times 2. 1 times 2 is 2, so that is going to go here. Our female is homozygous for big A, which means that she can only pass on one allele for this gene, one version, big A. Our female is also heterozygous for the B loci, or the B gene, so she's going to pass on 2 potential options for her eggs. So 1 times 2 is going to be 2. And then looking at genetic combinations in the offspring, sometimes my students get a little bit confused about how we arrived at some of these numbers. So you have 2 options. You can solve this in 2 different ways. Number one, you can do a Punnett square. So if we're looking at the A gene, or the A loci, solving out my Punnett square here, I'm going to put the male on top. Female goes down the side. And all of my options are going to be big A, little a. So that means that for the A loci, there's really only one combination, only one possibility, right? Looking at the B loci, or the B gene, so I'm going to draw out my Punnett square again. This time my male is going to go on the top, female is going to go down the side. So my genetic combinations are big B, big B, big B, little b, and little b, little b. So there are 3 potential different genetic combinations here. Big B, big B, big B, little b, and little b, little b. So that means my genetic potential combinations, 1 from the A loci, 1 from the B loci, means that 1 times 3 equals, woohoo, 3. I can also do this problem another way. So let me show you how to do it the other way too, the Dr. Sikora way that he showed you on your video. The way Dr. Sikora lays it out is he lays out each gene together. So, and all of the possibilities here. So if I'm looking at my A gene, potential possibilities for the A gene are big A, big A, big A, little a, and little a, little a. Looking at my A gene, so my male is little a only, so that means that I can't have a big A, big A. And my female is big A only, which means I can't have a little a, which means that my only possible combination is going to be little a, which is going to equal 1. My B gene is going to, I'm again going to lay out all of my possible genetic combinations and see what I can potentially get from this mating. So both my male and my female have a big B and a little b. So big B is a possibility. Both my male and my female and big B, little b is also a possibility because both my male and my female have a little b. And since, again, they both have a little b, little b is also a possibility, which means that I have 3 potential genetic combinations for my B. And again, 1 times 3 is 3. 3 possible genetic combinations in my offspring. So if we were to do this for number 2, looking at my male is going to pass on 2 potential combinations for big A, little a.
For Dawn, just to let you know, I do know how to use this system. This is a great time to be practicing it. If you have something to say to me, come and talk to me face to face. Thank you for your time.
I hate distance learning, you guys. I hate this so much. I hate making videos because I'm terrible at it. All right, so big B, little b. So that means that I'm passing on 2 potential combinations to my offspring for my male. So 2 times 2 is going to equal 4. 4 potential combinations for my male. My female also has 2 options that she could give to her eggs. 2 potential combinations for B that she could give to her eggs. 2 times 2 is going to be 4.
I'm just keeping my distance.
This school is ridiculous. In case you guys were wondering what happens at school while you're not here, this is what happens. All right, so let's lay out our potential genetic combinations. So for my A location.
Great. Now I need to start my 20-minute video all over. Thanks, guys. Just kidding.
Here are all of my possible potential combinations for my A location. Looking at my female, I have a big A and a big A in my male, so big A is a possibility. I have a little a in both my male and my female, so big A, and little a are also possibilities. So that's going to be 3 different options. For my B location, again, same deal. Big B's possibility, big B's possibility, little b's possibility, little b's possibility. So I get 3 options from there too. So 3 times 3 is going to be 9. So from number 2, I have 4 sperm, 4 possible eggs, and 9 total genetic combinations. Hope this clears things up a little bit for you. I'm sorry this video got so long. I also apologize for the interruptions. Let me know if you have any questions on how to continue to solve these. Basically, as each one goes, we add in a different location, and it just gets a little bit more complicated. So like I said, let me know if you have any questions, and I will try to help you out.